Now, the other thing about this is you're going to want to be looking for, because we're going to be shading in two different areas. Now you're going to be looking for the specific area where it's shaded twice. Okay, so again, it has to be true for both inequalities in this case, not just one of them. So it has to be shaded in both, from both lines. But everything else pretty much stays the same on this. If you get less than or greater than like this, you have a dotted line, I say dashed, whatever. And if it's less than or equal to or greater than or equal to like this one, then you get solid lines. Okay, so it's just a regular equation. Now what this means here is that the dotted line indicates that all the values on that line would be false. All the ordered pairs on that line would be false, okay? If it's a solid line, that would indicate that all the values on the line would make the original inequality true, okay? And I'm only referring to one of them at a time for now, but so you do graph the inequality like an equation, you know, put your y-intercept on there, use the slope to find the other points. So that's what I'm going to be doing in this section. If it's in standard notation, standard form, then I'll change it into slope-intercept form, okay? Now at the end, once you get everything graphed in terms of the lines, you got to choose a point on either side of the line, just like we've been doing. Generally speaking, we choose the origin if we can. Now again, we can only choose the origin as long as the line that we're testing does not go through the origin, okay? And then if it makes that true, then we shade on that side of the line. If it makes it false, then we shade on the other side of the line. That's it. Okay, but we're looking for an area that's been shaded twice, one by one of the inequalities, and then the second by the second inequality. That's it. So again, I don't think that this is really very new stuff. It's just you're going to be looking at two inequalities now instead of just old-fashioned one on this, okay? So I'm going to start with the second one there just because it's not in slope-intercept form. So I'm going to force it to be in slope-intercept form by first subtracting x from both sides. Now you'll have to keep in mind on this, well, we'll show it in the next step. Okay, so that zeroes out. I would drop this. This would be negative 4y, which is less than, I want my x term first. So I'm going to show it as negative x and then positive 10 like this. All right? And then I got the negative 4y, but I don't want negative 4y's. I just want a 1y, right? So I would divide both sides by negative 4 like this. Now, if we go back to, I think it was the last unit, module 3, so this becomes a phantom 1, but because you were dividing by negative, it would technically flip the inequality. Right now, I don't really care about it flipping the inequality because I'm not actually going to be testing anything with this new inequality, which means that I really could have just treated it like a regular equation. So yeah, this is now positive 1/4 x, but now it's minus, looks like 5/2 there, which isn't very pretty, I guess. Well, we'll figure something out with that. So we do have the slope at least from the second equation, which is up 1 to the right 4, because both are positive. But I can't really grab, I mean, you know, negative 5/2 would be negative 2.5, which is great. It's just when I go to put this on the graph, it's like, you know, I mean, I guess it's right there, but is that exact? I don't know. I guess it's pretty close. So looks like we may have to go back to the original equation and just kind of test some points out in there to see if it works. So, no problem. And I still haven't even graphed the second one. I'm not even worried about the first equation yet, right? So let's go back to the original inequality. X minus 4y. It's supposed to be less than 10. Really, right now, what I would like to know is where it equals 10, because I'm looking for the line right now. Okay, I don't care right now about the inequality. So even back then, up here, I could have put an equal sign there and an equal sign there. None of that would matter right now because I'm looking for the line, okay? So if I was looking at this, I'd probably say, you know what? Maybe make the x value a half multiple of 4, maybe. I think 2 should work. Let's try that. So I'm going to test an ordered pair where x is 2 on this. Now, this may take a lot of experimentation because of the fraction stuff. But I know if I put a 2 right here, with my principles of equality, when I subtract 2 from both sides, I'm going to get a multiple of 4. Okay, which means that 6 should also work. Maybe that'd even be easier, but I don't know. Let's find out, okay? So I'm going to solve this equation now for its corresponding y value, because I already know the slope, right? So I don't really care about any of the other ordered pairs. So subtract 2 from both sides. See, and then that makes it multiple of 8, right? So I drop this negative 4y equals 8. Divide both sides by negative 4. And with just a little bit more space, we can make this work. So y, it looks like the corresponding y value would be negative 2 on this. Okay, so I have 2, negative 2. That's fine. 2, negative 2. Where's that? 2, negative 2 right here. There it is. 2, negative 2. Yeah, there it is. I put the x-intercept on there. I don't want the x-intercept. Let's get rid of that garbage. I wanted the y-intercept, which is 0, negative 2.5. That's be about right there. There we go. I think that was a good mistake because we can learn from it. Now I'll use the slope to find all of my other ordered pairs on this line. So that's up 1 to the right 4, up 1 to the right 4. Boom, there's my next point. And I'll just continue this pattern. Of course, I can do it once more here. Looks like the x-intercept 10, 0. Doesn't matter. I'll copy this backwards. So left 4, down 1. And then left 4, down 1. Left 4, down 1. That seems to make sense. Okay. Now I would go back. I'd go back to the original inequality. So this is just a less than symbol right there, which means that this line should be dashed on this one. Okay, so I'm going to make it dotted just because for me it's easier. Not that it's pretty, but, you know, I'm trying my hardest. Something like this. I think I'm better on paper, but I can say all I want to. I actually feel pretty good about that dash one, the dotted line I just put out there. Okay, so there's my dotted line. And again, why is it dotted? Because all the values, all the ordered pairs on this line right there that we just drew would be false in the original inequality here. Okay. So I've got that line, and I'm going to test the origin with that inequality. Okay. So I am going to test 0, 0, origin, in the original inequality, which was x minus 4y. And at this point, I do want the inequality portion of it, so it's less than 10. Okay, because I'm now looking at points outside of the line. So this is where we're looking at inequality comparisons. But I'm going to replace the x and y's with the x and y values from the ordered pair 0, 0. So x is 0, put in parentheses if you'd like, and the y value is 0 as well. Now you could put this in the calculator, right? 4 times 0, 0, and I'm just checking for truthfulness right here. So 0 minus 0 is just 0. Is 0 less than 10? Yeah, that's true. Now, since this is true, that means that I could shade. I'm going to say that's above the red line, just because of its slope. If it was more steep, then I'd say left and right of that line, but it doesn't matter. Okay, as long as you shade the correct side of the line. So I do it like this, right? And if we were just graphing one inequality, that'd be great. And don't ask me to shade between the lines, right? But whatever. Now we do have the other equation. We have to check. Okay, so let's look at this one. But this one, pretty much all the information that we need is right there. We know that the slope here, I'll do this one in green, the slope is negative 2. So I'm going to say that's down 2 to the right 1. And the y-intercept, if I haven't emphasized this enough, just be careful not to say it's 2. Because if you put 2 on an exam, which is next time, you'd lose a point. It has to be 0, 2, okay? I know we're graphing, so you wouldn't necessarily need that, but when it asks for a y-intercept, you need to show that as an ordered pair, okay? So I put my ordered pair, my y-intercept at 0, 2, which, if I can do this right, because I made that mistake last time, right? 0, 2, there we go. And then I've got a slope of down 2 to the right 1. So let's go down 2 to the right 1, down 2 to the right 1. We see a little point of intersection, which for a regular system of equations, that would be enough. But since this is a system of inequalities, we got to continue that, okay? So there's my stair steps, and I can continue that backwards, especially when I'm doing this by hand, so it looks pretty. Not that it always does, but again, I've done worse. So there it is, okay? So I have all the points for my line. Is it a solid line or a dashed line or a dotted line? Well, this one's a solid line because it's also equal to the y right there. So it's a solid line. I'll go to some technology for this one. Not have to suffer through my very pretty lines. Okay, well, there we go. Now, I need to test one of the sides of this line, and of course, this line does not go through the origin, which means that I can also test the origin in the original inequality. So, that was y is less than or equal to negative 2x plus 2. But now I'm going to test the same ordered pair, the origin, and see how this comes out. Okay, so there's a 0, 0. A question mark. So negative 2 times 0 is 0. 0 plus 2 is 2. So I'm comparing 0 with 2. Yeah. 0 is less than or equal to 2. Yep, that's true. And of course, it's not equal to 2, but it is less than, and that's all we need is just one of those two conditions to be true. Since it is true, I'm going to say that the test point that we used is on the left. So that means I would shade to the left of our green line right there. So you can see now, especially with technology, I guess, that the intersecting shaded area is this, now it's a blue area right there. Still a little sloppy. I'll show you how to do this if you just have a pen or pencil though. But I really do hope the color coding kind of helps us with that. Okay, so this also means that if we're going to go back and really clean this up, if the technology will let me. There we go. Well, I wouldn't say that's really fully cleaned up, but that's pretty enough, I think. And that's how our graph would look right there. Boom. Okay, so that means that any point on the green line up to this red point right here, and all of the shaded area, any ordered pair there would make the system true. Not just one equation, but both.